All right. So functions are kind of like machines. Think of this weird machine where you put things in and the machine processes whatever you put in, it processes it. It does some processing. Look at the gears are right here. It does something to the input and then it spits out an output. Okay? That's how I want you to start thinking about functions. We've been dealing with functions, the domain and range. Are they continuous or discontinuous? Are they a function, yes or no? So, because not all graphs are functions, not all relations are functions. But you have inputs, you have outputs. So on that first machine up on top, I'm going to write example 1 next to it on the left. You're not going to turn these notes into me, they're for you. So you can kind of organize them the way you see fit. Let's go to make a little table of values. The first input they already provided for us, -2. Give me an x and y table, maybe on the left or the right side, anywhere there's an empty space, yeah. Just use the space the way you see fit. I mean, I kind of made that note guide paper kind of quick, so I should have made some more space between the machines, but just deal with it as you see fit. How about -1? How about 0 and 1? Okay. So the first input is -2. So look at the function. Y equals whatever you put in for x. The y will equal 3 times the x. So let me do the math right here. So look at inside the machine is a -2. So I'm going to put 3 times -2, so y becomes -6. They did it for us. Nice. Look at -2, -6. Nice. So far, so good. Let's try the next input. Three times. The next input is -1, I put. So 3 times -1, what does that become? -3. So far, so good. So about half the page, make an x and y axis on your graph paper. 0, 0, and 1, 3. Plot those puppies. So -2, -6, -2, -6, 2, 3, 4, 5, 6, -1, -3, (0, 0, and 1, 3. Now, would this be a continuous function or a discrete function?
Discrete.
Right now it's discrete, but in actuality,
Continue.
I can put all kinds of inputs. I could put, how about 0.5? 0.5, a fraction. So watch this, 3 times 0.5, that becomes 1.5. No, does it? Yeah. 1.5. So look at this. 0.5, 1.5 is right there. 1/2 on x and then 1.5 on y. So this is a continuous function. The way I plotted it, it looked discrete, but x can be anything I want it to be. In other words, I can throw anything, any number. I can throw any number as an input on the number line, and it's going to spit out an output. Any number you can fathom in your mind on the x-axis, there's going to be some y output forever. That's why I put arrows here. These arrows indicate that line goes on forever, so x can take on any value. You can throw in any value of x into that machine. The domain's infinite. So is the range. So what kind of function is this? This is called a linear function. Linear function. Why do you suppose we call it linear? Right, the word linear has the word line in it. It's right there, the word line. They create lines. Okay? So far so good. Okay. Let's go to the second function now, the second machine. Let's go to example 2. That was a linear function. Copy that puppy. So again, yours is kind of crowded there, the way I copied that paper, I apologize. Go to write example 2. But let's go ahead and change the machine right now. Okay, let's change the machine. Let's not make it y equals 3x. That's not what the machine's going to do. Cross that out. Let's make it y equals x to the second power. Do that for me. So the machine now is whatever input you give the machine, it's going to take it to the second power. The first machine, the first function, took every input and multiplied it by 3. Now the machine's going to take every input and take it to the second power. So let's go ahead and make a x and y chart. -2, -1, 0, 1.
Is that music peaceful, mister?
Big time. Goes good with functions, the beat. Just kidding. So y is -2. I'm replacing x. Look what the function is taking that input and squaring that puppy. So y is 4. Nice.
Trains go well too. Trains also go well with your morning coffee.
Huh. So now we gotta go, the next input in line is y equals -1 squared. Well, that becomes -1 times -1, which becomes +1. Nice. So far so good. 0 squared. Putting stuff in the machine, inputs in the machine. That's gonna be 0. Next in the machine, a 1 squared. 1. All right, let's graph this puppy. Going to make another x and y axis. There we go. -2, 4. -2, 4. Okay. -1, 1. All right. So far, so good. 0, 0. It's not looking like a line. That's for sure. 1, 1. Interesting. If I were to continue putting a bunch of inputs into this equation, into this function, it would end up forming a parabola. comes down, it comes back up, it goes forever up like this. But I just stopped at 4 inputs. Once, but I can put all kinds of inputs. I can be here all day putting inputs, and it's going to form what you just saw right there. It's going to form that function, that graph. Now, so for those of you on the video, that's called a quadratic function. All right, so it's taking every input now and taking the cube root of that puppy. The cube root, here we go now. Oops. The cube root of -2. What number to the third power becomes -2? Are you kidding me? You put a gun in my head, I wouldn't know what to say. What'd you say from your mind? What number to the third power becomes -2? Forget it. You're done. You're dead with me. So, calculator time, baby. Cube root -2. So let's go. I mean, it's an infinite decimal. What we'll do is to the nearest tenth, the first decimal. So -1.3. So I'm rounding the first decimal, -1.3, approximately. Okay. -1.3. So far, so good. Cool. By the way, I shouldn't have put y. Let's go f of x. Let's go into higher gear now. We're Math 3 students. All right. What's the function now at -1? Well, here we go. Cube root of -1. Again, someone put a gun in your head. What's the cube root of -1? You're done. So let's let the calculator do the work.
Let me see. Let me check Desmos. Wait a second. Don't come.
Bust out your smartphone, Desmos. So I'm just gonna erase that puppy and type in -1. Maybe not. All right, cool. Oh, it was -1. And that makes sense. -1 times -1 is +1. +1 times -1 is a -1. The -1 third power is going to be -1. All right, we're getting somewhere now. Here we go. The output's -1. All right. Now, what's the function at 0? I think if someone put a gun to my head, I think I could probably do that one. What to the third power is going to be 0? 0. Thank you, Diaz.
See, if I was at other school, I could have got suspended.
Because you put a gun. All right.
No, it doesn't make sense. I'll take that as a threat.
No, all right, got you. They kind of scare me though. You had that killer look there. I was like, whoa. All right. The function at 1, the cube root of 1. Now I think I can probably answer that one if you put a gun to my head. 1 to the third power is 1. Right? 1 to the third power is 1. The function at 2. Cube root of 2? I would go with positive. Look at since -2 is a -1.3. I'm gonna go with positive 1.3 to see if my life was saved. Diaz is pointing the gun at me. She's for 45. Let's see what happens.
It's a 9, mister.
All right, then I got a chance. So that's 2. Yes, my life is salvaged.
Salvaged.
Positive 1.3. So far, so good. Any questions? Let's go and graph this now. Flip your graph paper or wherever you want. Remember, you're not turning your notes. You organize your notes the way you see fit, but I'm going to go and graph this puppy. -2, -3, or -1.3. Here we go. -2, -1.3 is about right there. Right? 2, and negative 1.3. A little bit past, not quite 1.5, but it's a third of the way down. 1 and 3/10 down. Negative 1, negative 1. Huh, interesting. 0, 0. All right. 1, 1. All right. Kind of looks like a line, sorta. And then 2, 1.3. Okay, now it's not looking like a line. Something's going on here.
Looking like a swerve.
Yeah, it's like a swerve or a swirl or something. Now, to check my work, and this is what I want you to do as you do your own, to check your work, I'm going to go to Desmos again, but I'm going to go to the graphing calculator this time. And I'll put the links of both. Let me just double check my work. F of x is equal to cube root. F of x. Cube root. Type right here, this button has all the functions here. Let's go cube root. Maybe not.
Click functions, maybe?
And we're going to have to do, unfortunately, we're going to have to translate the cube root. And, well, let's see. Do you remember how the cube root of x is really x to the what power? Remember? The what?
The third power.
Close. Remember that becomes a denominator? It's really x to the 1/3 power.
Right.
That and that mean the same thing? So we're going to have to remember a couple of weeks ago that the cube root was really the same as 1 over that index. It's a rational exponent. So let me punch that in then. So x to the 1/3 power is going to have to suffice. Oops. X to the, watch this now, 1/3. Okay, so it is a swirl. So look at the domain. Goes forever. Comes right here. So we're just hanging out right here. Our grass is right here because we only plotted like 4 points. This is where we're hanging out right here. So let's go ahead and finish that swirl. Comes like this. Comes up. Put arrows on both ends. This is called a cube root function. Cube root function. So far, so good. All right. Now,